Hello and welcome to the Data Engineering Podcast, the show about modern data management. Dagster offers a new approach to building and running data platforms and data pipelines. It is an open-source, cloud-native orchestrator for the whole development lifecycle, with integrated lineage and observability, a declarative programming model, and best-in-class testability. Your team can get up and running in minutes thanks to Dagster Cloud, an enterprise-class hosted solution that offers serverless and hybrid deployments, enhanced security, and on-demand ephemeral test deployments. Go to dataengineeringpodcast.com/Dagster today to get started, and your first 30 days are free. Data lakes are notoriously complex. For data engineers who battle to build and scale high-quality data workflows on the data lake, Starburst powers petabyte-scale SQL analytics fast, at a fraction of the cost of traditional methods, so that you can meet all of your data needs, ranging from AI to data applications to complete analytics. Trusted by teams of all sizes, including Comcast and DoorDash, Starburst is a data lake analytics platform that delivers the adaptability and flexibility a lakehouse ecosystem promises. And Starburst does all of this on an open architecture, with first-class support for Apache Iceberg, Delta Lake, and Hoodie, so you always maintain ownership of your data. Want to see Starburst in action? Go to dataengineeringpodcast.com/starburst and get $500 in credits to try Starburst Galaxy today, the easiest and fastest way to get started using Trino. Your host is Tobias Macey, and today I'm interviewing Paul Dix to talk about his investment in the Apache Arrow ecosystem and how it led him to create the latest fad in database design. So, Paul, can you start by introducing yourself?
Sure. I'm Paul Dix. I'm the founder and CTO of InfluxDB. We are the makers of InfluxDB, which is an open source time series database. Prior to that, I have a lot of experience in industry. I'm obviously a computer programmer by training, and I've worked in a lot of large companies, small companies, all over.
And for folks who haven't listened to your previous appearance on this show, where we were talking about the Influx product suite and your experience there, where you actually hinted at the work that you've been doing, where we're bringing you back to talk about. Can you just give a refresher on how you first got started working in data?
So as I mentioned, InfluxDB is a time series database. Now, how I got interested in this topic, I mean, generally, like when I was in school, I was interested in information retrieval, database systems, that kind of stuff. But in 2010, I was working at a fintech startup here in New York City, and we had to build a solution for working with a lot of time series data. Later, when I started this company, initially we were building a product for doing server monitoring and real-time application metrics and that kind of thing. And to build a backend for that, I had to build a solution that was very similar to the backend I had built for the fintech company. So I saw two different use cases. One was in financial market data and the other in like server monitoring and application performance monitoring data. But the backend solution for both was basically the same thing. And at that point, I realized building a database that could work with time series data at scale and make it easy for the user was a more interesting problem to solve. So, we pivoted the company to focus on that, became InfluxDB. And we've been building for that ever since. So initially we had, version 1.0. The initial announcement of InfluxDB was in the fall of 2013. We released version 1.0 of InfluxDB in September of 2016. We released 2.0 in basically late 2019, early 2020. And then just this last year, we released version 3.0 of the database, which is the significant rewrite that you were hinting at that basically caused us to adopt all these new technologies and start investing heavily in the Apache Arrow ecosystem.
Now, bringing us through to this part of the conversation, I made a little bit of a play on the acronym with the introduction, but the different letters of it are FDAP, and I'm wondering if you could just start by describing the overall context of that stack, what the different components are and how they combine to provide a foundational architecture for database engines.
Yeah, so the FDAP stack is an acronym for the different pieces. F stands for Flight, which is Apache Arrow Flight or Apache Arrow Flight SQL. A is actually Apache Arrow, which is essentially the foundational project under which all these components reside. So Arrow is like the umbrella project for everything. So Apache Arrow is an in-memory columnar specification. So basically it's a format for in-memory columnar data so that you can do quick analytics on it. D which is Datafusion, which is a SQL processor. Like it's a query parser, planner, optimizer, and execution engine for SQL. Specifically, also it follows the Postgres dialect of SQL, and Parquet, which is a file format for persisting columnar data, but also structured data. So you can have nested structures. It's essentially an open source implementation of the Google Dremel research paper that came out in the early aughts.
I'm wondering if you can talk to the design goals and constraints that you were focused on in the reimplementation of InfluxDB and how that led you to the selection of this composition of tools to execute on that vision.
Yeah, so for InfluxDB 3.0, as I mentioned, we basically did a ground up rewrite of the database, which generally speaking is not something you'd ever want to do, but there are a number of problems we wanted to solve for. So first is this idea of infinite cardinality, right? Within time series databases, generally there's this idea of the cardinality problem where cardinality comes in like dimensions that you describe your data on, right? So these could be like a server name or a region or a sensor ID, but you can also have other dimensions like what user made this request or what security token made the request. And really, when you think about it, the dimensional data is basically just data that describes different observations that you're making. So when people want infinite cardinality, they basically just want to be able to say they want to capture as much precision and information about these observations that they're making. Now, traditional time series databases like InfluxDB versions 1 and 2 and others have a problem essentially when this cardinality gets super, super high. And we had a bunch of customers and users who were saying they wanted to record this and use InfluxDB for it, but we didn't have a solution. It was basically like a fundamental limitation of the architecture of the database. So how do we achieve infinite cardinality? How do we achieve cheaper storage, right? People wanted to decouple the query processing and the ingestion processing and indexing from the actual storage of the data. And they wanted to be able to ship historical data off to cheaper object storage that could be backed by spinning disk while still making it so that queries against recent data are super fast, right? So again, you're talking about a very fundamental shift in the architecture of the database to be able to enable, keeping everything in object storage while processing recent data in memory and all this other stuff. So there's that. And then the other big piece is essentially like we wanted broader ecosystem compatibility, right? InfluxDB versions 1 and 2 have their own query languages, their own data formats, right? We wanted to be able to integrate with a much broader set of third-party tools. So specifically, we wanted to support SQL as a query language, in addition to InfluxQL, our older query language. We wanted persistence formats that could be read and used in tools outside of InfluxDB, right? So, and we wanted all of this essentially to be super performant. And basically when we looked at this, we're like, okay, there are fundamental architecture changes of the database, which means we're essentially going to have to rewrite most of it. And this was at the beginning of 2020. And at that time, I thought, well, one, older versions of InfluxDB are written in Go. That's kind of an artifact of when we created the project back in 2013, right? Go is starting to become hot then, right? The Go 1.0 release was in March of 2012. But in 2020, the beginning of 2020, I was very interested in Rust. And I felt that Rust as a programming language would be essentially the best way to implement this kind of like high performance server-side software. And I also thought that we could bring in other open source tools and libraries that would help us get there faster. Specifically, like we didn't want to create our own SQL execution engine from scratch, right? That's a very, very big investment. And there are other systems out there that could do it. And initially, we thought that we might be pulling in something that was written in either C or C++, which meant like bringing that code into a Rust project is actually fairly straightforward. And you have like zero cost abstractions and basically a very clean way to integrate it. But when we started looking around, we saw that there were actually some Rust projects that were super interesting, right? That would enable us to do this. So one, persistence format, right? We wanted a format that was more broadly addressable, right, from other tools. And in 2020, the most obvious choice, at least to us, was Parquet. It was still like Parquet came out, I think, in like 2016. So it was beyond like the early adopter phase, and it was getting more usage, starting to get more usage in like other big data processing systems, data warehouses. And we felt that if we use that as the persistence format, we'd get the amount of compression we needed for our data to make it like, compact at scale. But the other is like make it so we could share it with other third-party systems. So that was kind of an obvious choice. Then we knew like we needed fast analytics on the data, right? So that's when we started looking at Arrow as the like in-memory columnar data structure, right? One of the things I mentioned is, this need for supporting high cardinality data. But then the other need is essentially like doing analytic style queries on time series data so that you can do analysis. Versions 1 and 2 of InfluxDB, those kind of analytics queries were like slow because of the way the system was architected under the hood. And we thought if we're going to be able to do fast analytical queries on time series data, it's going to have to be in this columnar format. So we kind of adopted Arrow as the in-memory format for this data, which then led to, these other pieces. And then in early 2020, we looked at a number of different query engines we could potentially use. We looked at DuckDB, which was still very nascent at that time. We looked at ClickHouse's engine, which again was nascent compared to where it is now. And we also looked at Datafusion. And at the end of the day, we decided that Datafusion would be our choice because, it was written in Rust. And the thing is, like all three of those projects that we evaluated, we realized there was going to be a lot of work that we would have to do to be able to support the time series use cases that we were aiming for. And we felt that if we're going to have to do a lot of work and end up contributing heavily to this query engine, we might as well do it in a language that we intend to use, which is Rust, right? DuckDB and ClickHouse are both implemented in C++. And we also felt that Datafusion being part of the Apache Foundation and being part of the Arrow project, we were making a bet that it would essentially like start to gather momentum and pick up steam, and there'd be other people who would contribute to it over time. And over the last, 3.5 years that we've been heavily developing with it and contributing to it, we've certainly found that to be the case. Is more people have been adopting Parquet, more people have been adopting Arrow. They've been contributing to those two and Datafusion, and Flight and Flight SQL are also becoming kind of a standard RPC mechanism, essentially for exchanging, analytic data sets or, millions of rows quickly in a high performance way.
And each of those pieces of the stack are definitely well engineered. They've been gaining a lot of momentum. There's been a lot of investment in that overall ecosystem, but they are all, I guess they're not as narrowly scoped, in particular Arrow, as when they first started, but they are all focused on a particular portion of the problem. And in order to build them into a cohesive experience, I'm curious, what was the engineering effort that's necessary to actually build a fully executable database engine and platform experience on top of those disparate parts?
Yeah, I mean, it's certainly true that when Arrow first started, it essentially was like an in-memory specification. And the dream there was essentially that, you have data scientists who are trying to do analysis in either Python or R, right? And the thing is, they almost always have to get their data from one place and bring it in and exchange it to another thing. So the vision there was essentially, how do you do data interchange between these different data science tools and systems that is zero copy, zero cost serialization, deserialization, right? Super, super fast. And Wes and his team started with that. And then they saw like, okay, wait a second. Now people also have these needs to like persist the data. So we need a persistence format. He brought in Parquet because he also helped define Parquet when it was first created, but that became an obvious add-on. And then, the RPC mechanism, they're like, okay, now you have servers that are running things. So you need a way to exchange the data. Again, an obvious add-on. And Datafusion, again, like if you're working with this data, like in Python, you have like pandas, and R, you have like these, different things. You have like either data frames libraries or whatever. But a lot of the time, people just want to execute a SQL query, and you need an execution engine that can work with this Arrow format natively that's going to be super fast, right? Anything that's fast in Python isn't actually written in Python. It's written in C or C++, and then wrapped. So that's what they realized from the data science perspective. Now, from the perspective of people creating a data platform, like an entire data platform or a database server or something like that, the thing that's tricky about it is a lot of these formats are actually, they're designed for exchanging like a set chunk of data, right? Like Parquet is an immutable format, right? It's not meant to be updated. You write a Parquet file and that's that. Arrow, again, like you don't append to arrow buffers on the fly. Like you create an arrow buffer, it's well defined, and then you can hand it off. So having a system that's basically able to ingest data live, right? Like individual writes, individual rows that you're writing in, and being able to combine that with this historical data set that's represented either as arrow buffers in memory or Parquet files on disk, right? Moving all that data around, that becomes the really like the trickiest part of creating like a larger scale data platform. It's like, how do you move that data around? How do you combine the real-time data with the historical data? And how do you make that all fast? And how do you make it easy to use? All of that work is basically a non-trivial amount of effort, but it's certainly made easier by the fact that you no longer have to create the lower level primitives, right, to build that data platform. You don't have to create the query engine. You don't have to create the file format, right? Those things basically just exist. And they're, I've heard Wes refer to it as basically the composable data stack, right? Which is you can kind of pick and choose these pieces that you want to work with, right? You can use the Datafusion query engine, but not use Parquet at all. And not use Flight if you don't want to. It uses Arrow under the hood, so that kind of like comes along for the ride. But yeah, like all of these different pieces are kind of like, they're designed to be modular so that you can pick a different persistence format if you want that. You can pick a different execution engine, right? Within the Arrow ecosystem, one of the things that Voltron Data, the company that Wes ended up starting with some other people that backs a lot of the Arrow stuff as well, one of the things they created was this project called, I don't know how to pronounce it, Velox, basically, VELOX, which is basically like this execution engine that was created in conjunction with some work at Facebook to do stuff, right? So the idea is you can pick and choose these components and kind of tie them all together into a larger like operational system where you're essentially solving problems around data warehousing, real-time analytics, and essentially just like working with what I would say observational data at scale, right? Where observational data could be data from your servers, applications, sensors, logs, whatever it is.
Are you sick and tired of salesy data conferences? The ones run by large tech companies and cloud vendors? Well, so am I. And that's why I started Data Council, the best vendor-neutral, no BS data conference around. I'm Pete Soderling, and I'd like to personally invite you to Austin this March 26th to 28th, where I'll play host to hundreds of attendees, 100 plus top speakers, and dozens of hot startups on the cutting edge of data science, engineering, and AI. The community that attends Data Council are some of the smartest founders, data scientists, lead engineers, CTOs, heads of data, investors, and community organizers who are all working together to build the future of data and AI. And as a listener to the Data Engineering Podcast, you can join us. Get a special discount off tickets by using the promo code DEPOD20. That's DEPOD20. I guarantee that you'll be inspired by the folks at the event, and I can't wait to see you there.
Another interesting element of building your platform on top of all of these open source components is that by virtue of it being a layered stack, you can have additional integrations that can come in at each of those different layers rather than having the main interface be the only way of accessing the data that it contains. It also gives you the benefit of being able to capitalize on the overall ecosystem of investment and the network effects that you get from those different open source projects. So I'm wondering if you can comment on some of the ways that you've seen that benefit materialize in your work of building this data platform on top of these different components.
Yeah, so this is actually like one of the things I'm most excited about for these different pieces and for the work we're doing, which is I think we actually need to add another letter to the acronym, the FDAP acronym, and maybe like jumble them up. But basically, the other letter is I for Apache Iceberg. So Iceberg is essentially a catalog, a standard for creating a data catalog of essentially Parquet files in object storage, right? And we're basically building first class support for that in InfluxDB 3.0, where all of the data that's ingested into an InfluxDB 3.0 server can be exposed essentially as Iceberg catalogs, which is awesome because that's a standard that was originally developed at Netflix and that was open sourced out into the Apache Foundation, and it's quickly being adopted by other companies, right? So Snowflake just added support for Iceberg as a format. Even Databricks is adding support for it, even though they have a competing standard called Delta Lake, and a lot within Amazon, the Amazon Web Services, for example, they're adding first-class support for Iceberg, so that if you have data that's exposed as an Iceberg catalog, in S3, you can then query that data using any of the Amazon, query services like Athena or Redshift or all these different pieces. So that I think is like a really interesting integration because it makes it so that you can access this data in bulk, right? So if you need to like train a machine learning model or whatever, or query against this data for doing large scale analytical queries and be totally outside for InfluxDB 3, for example, totally outside the operational envelope of the system that's kind of like managing all this real-time data movement and being able to query in real time. You can basically do all these analytics tasks completely disconnected from that. And again, like you could use Datafusion for that, but you could also use Athena, right? Which is, based on a Java query engine called Trino or Presto or whatever it is now. Or you could use DuckDB or ClickHouse or any one of these other systems to do your query processing and analytics against that data. So that integration, I think, is super interesting. The other one that I think is interesting is within the Arrow project. So they have Flight SQL is basically like an RPC mechanism for essentially sending SQL queries to a server and getting back millions of rows really, really quickly. And they have basically a new standard that they've created that's kind of like competing with ODBC. So ODBC is obviously the database connection standard. It was for essentially transactional databases and relational databases. The Arrow one, once that becomes a thing, I think it'll be a really like a standard way to connect to analytical data stores of any kind, whether it's data warehouses or real-time data systems or whatever. And I think those, like having those things be standards and have them, contributed to by many different companies, not just supported by a single vendor, I think will make it the pace of innovation in this space for these, large scale data use cases, which are only going to continue to like increase and multiply. I think it makes it so that we can have basically many more tools that can integrate with each other. Whereas like if you look at data warehousing, for the last 20 years, it's largely been like your data warehouses are basically kind of like data roach motels. Like your data goes in and you have to get all the data in the data warehouse, but then if you want to do anything with it, you have to send the query to the data warehouse and like all this other stuff, right? And there's not this really good integration. Like the data warehouse just becomes this one place. So being able to access it from a bunch of different tools without having one piece of software be the arbiter of the entire thing, I think is really interesting.
Absolutely. And to your point of Flight SQL being a new RPC mechanism to unlock a lot of potential and reduce a lot of the pains, it just makes me sad that I obtained all of that scar tissue around ODBC for nothing.
I mean, I think ODBC is going to be around for a very long time. I don't think it's going away.
Yeah, absolutely. And the counterpoint to the benefits that you get building on top of open source is that, particularly when you have a business that is being powered by these components, you adopt some measure of platform risk because you're not the only person who has a vision for the future direction of these technologies. And some of that future direction may or may not be compatible with the vision that you have for it. And I'm curious how you think about that platform risk and the mitigating factors that you have in the engineering that you're doing to account for any potential future shift in the kind of vision and direction of those products.
Yeah, I mean, you can wrap the libraries with your own abstractions, but the problem is that comes with a high price, a high cost. And the truth is, even if you wrap it with your own abstractions, if the libraries end up changing significantly and you're like, okay, we need to replace it with something else, it's going to be like a non-trivial task, right? The best insurance is essentially to have enough people contributing to the core of the thing to be able to have some level of influence on the direction of the project, right? Like ultimately there's going to be platform risk, but I think, take it from the other side, which is we decide to develop all this stuff ourselves, right? And keep it closed source and just, whatever. Well, the risk there is like, I mean, that's just an absolute mountain of work to do, right? And the thing is like, as these projects have matured, like I said, like we've seen other people contributing to them. So now we regularly get like performance improvements in the query engine or new functions in the query language and all this stuff. Like we help manage the project. Like we have people contributing to, we make significant investments into the open source pieces, but those are things that we kind of get for free as a result. Like essentially, like it means that the risk we have if we kept it all closed source is that our pace of development would be outmatched by the set of people contributing to this open thing, right? We may be able to get somewhere initially, but like eventually like the open source people are going to like outpace a small team of proprietary developers. Now, if you have unlimited resources and you can basically just like create a long-lived team of people that you're able to fund forever, then the situation changes. But I think for startups in the technology space, like the best bet is to adopt platform pieces that are not that you can contribute to, that can form the basis of the things you're building, right? Like, and this is you don't create your own operating system, right? You use Linux, and you don't create your own programming language. You use whatever language you're going to use there. And I think all that stuff happens, it happens higher and higher. All these pieces kind of like build on each other. And in this case, like when we're talking about the FTAP stack and all these different components, they're essentially the toolkit that you would use to build a database, an analytical database or a data warehouse, right? So why create those things from scratch, right? Your ultimate goal is not really to create a data warehouse. It's to deliver, value for your customers who are actually paying for the solution. And they don't really care about a data warehouse per se. They care about solving their data problem for their customers. So as much as you can like adopt to say like, okay, this isn't going to be our thing that we innovate on. This is going to be that's not how we actually like add value to this market, to this thing that we're selling. This is basically just like a barrier to entry. And if you can adopt an open source thing that like reduces the barrier, then great.
Absolutely. And by virtue of being involved with and participating in the open source projects that you're relying on, you also get the benefit of early warning, of knowing that, okay, this is the future direction that the community would like to see. And so now I can proactively plan for those shifts in the underlying technology so that I can accommodate them in the end result that I am building on top of it.
Yeah. Yeah. Well, and ultimately, like the absolute worst case scenario, right, is like the community is going to make some weirdo changes. They're just completely incompatible with what we need to do. Great. Then we can just fork the project from whatever that last point was. It's permissively licensed open source. We can fork the project, and then we have two options. Do we make our fork closed source, or do we make our fork something publicly available and you just continue on from there, right? And at that point, you haven't adopted any more risk than you would have had anyway, is, your closed source thing. Although I will say, like I mentioned, we spend a lot of time contributing to these community projects. So there's a good amount of effort that we put forward that essentially doesn't benefit us directly, right? It's not that we're doing this community thing or managing these like efforts of different people contributing or whatever, because it's something we need specifically for our product. But again, the bet is that, okay, there are a bunch of things we'll do that are not direct benefit to us, but there are other things coming in from the community that are. So it all kind of like evens out. And actually, in my experience, it doesn't even out. Like, we get far more out of it than we put in, even though we, like I said, we try to put in as much as we possibly can. It's just that when you have, dozens of developers from around the world in different companies contributing to this thing, like the sum is going to be greater than what any one individual or one company produces and puts into it.
And so looking at the component pieces of this stack and the overall architecture and system requirements for a database engine, what are the additional pieces that you had to build custom? What is the work involved in building a polished user experience on top of these different components? And some of the ways that you're thinking about what are the appropriate abstraction layers, or what are the appropriate system boundaries for what these four pieces of the stack do and the eventual inclusion of Iceberg, and what is the responsibility of Influx as the database experience that needs to be built on top of it?
Yeah, so I mean, basically, like, these components are really just libraries, right? They're just programming libraries that we use. So they're not actually a piece of running software that will do anything on its own. I mean, Datafusion does have like a command line tool where you can say, like, point it at, a file and execute a query against it if it's CSV or JSON or Parquet, right? But beyond that, it's not like a process that will run on a server that will respond to requests and all this other stuff. So you kind of have to build all that scaffolding around it, right? You have to build a server process, and you have to decide what your API is going to be, right? For writing data in, most people are not going to want to write, Arrow record batches or Parquet files in, because those two formats actually aren't super easy to create yourself. Like, usually when people create those formats, they do it as a transform from some other data that's easier to work with, like CSV or JSON or whatever, right? So you have to decide, like, how do you write data in? What's that format? How do you translate it to Arrow or Parquet? You need to decide, like, for the query interface, like, SQL's the language, but then how are they going to make the request, right? Is it going to be HTTP, gRPC, whatever? And then what is the response format going to be? Do you want to give them Arrow? Do you want to give them Parquet? Do you want to give them CSV, JSON, something else, right? So all those pieces you kind of have to decide on and create, right? Basically the entire, like, piece of server software. And then there's, all the operational pieces, which is if you have to run this in a Kubernetes cluster, if you have to run this in the cloud or whatever. And also for us, for InfluxDB 3, we have currently, what we have is a distributed version of the database where it's comprised of a number of different services that run inside a Kubernetes cluster, right? And we've separated out the ingestion tier from the query tier, from compaction, from a catalog that runs, right? So we basically had to create services for each of those and APIs for how they interact with each other, and then a bunch of, like, tooling and stuff like that to actually monitor, spin this up on the fly, monitor it, run it, all that separate stuff. So, I mean, there's still, like, if you're going to adopt these components to build, a data system, there's still a lot of work to do. But yeah.
For people who are interested in building some database engine, or they are interested in the functionality of any of these different pieces, I'm curious what you see as some of the other types of projects that would benefit from the capabilities of any or all of those pieces of the stack, and maybe some of the other elements that could be built up and added to that ecosystem to maybe reduce the barrier to entry that you've had to pay?
Yeah. I mean, so what I've seen, like a bunch of different kinds of projects are starting to adopt, and companies are starting to adopt these pieces of the stack. So, I just saw one yesterday. There was basically like a new stream processing engine that essentially is using Datafusion and thus also Arrow as the way to do processing within the stream processing engine, right? So you can execute SQL queries against like data coming in a stream, whatever. So there's that. There are different kinds of database systems, either time series database or document database or data warehouse or whatever. Like I've seen a number of projects in either open source or in companies that are starting that to use those components. There's another project right now where contributors from Apple are basically putting in essentially a Spark execution engine, which is based on Datafusion. Essentially, this is replacement for the open source Java Spark implementation that's supposed to be faster and stuff like that. So basically, you see like one component within Spark is being replaced with Datafusion as part of this. And actually, the creator of Datafusion, Andy Grove, was originally creating Datafusion for that use case inside of NVIDIA. So you see like all these different companies like creating those different pieces. I think it's still early for the Rust ecosystem of tools to see what's going to happen, like what open source projects are going to become kind of big, right? Right now, when you think of like big data processing tools, most of that environment is in Java, right? It started with Hadoop and then continued with Spark and like all the different components there. And right, and Kafka's written in Java and Flink's written in Java, right? So you have different stream processing systems and all these things kind of integrate together. What I anticipate is that, over the next 10 years, you see a lot of those systems rewritten, recreated using Rust and using Datafusion and Arrow and Parquet as the underlying primitives. And ideally, they wouldn't just recreate the exact same thing, but instead of Java, it's in Rust. There will certainly be some of that, but ideally what they will do is they will take, a lot of lessons learned from those previous versions of those pieces of software. Because okay, how can we make the user experience better, right? So it's easier to express the kind of things we want to express, or how do we make operations better? So it's easier to like operate these systems at scale. So I think it's really early yet though. It's not clear to me, like, from an open source perspective, what projects are going to be the winners here that eventually supersede the previous Java systems.
Absolutely. And I've definitely been seeing a little bit of that as well, even 3 to 5 years ago, of C++ being the implementation target, particularly built around the C* framework for being able to take advantage of multi-CPU architectures, most notably the ScyllaDB project as a target to re-implement Cassandra, and then Red Panda taking on the Kafka ecosystem.
Yep.
And another interesting aspect of this space is Arrow as the focal point of that data interchange has been gaining a lot of ground. It started off as a very nascent project. There's been a lot of effort put into making that more of the first target rather than being a second consideration. And it's been working on integrating with the majority of the components of the data ecosystem. I'm wondering what you see as some of the remaining gaps in coverage or some of the white spaces in the overall Arrow ecosystem that are either immature or completely absent, and spaces that you would like to see the overarching data community invest in building out more capabilities and capacity.
So I think there's still probably some work to be done within Arrow as a specification itself for representing data in a more compact form. Right. For some kinds of like columnar data, it's just not as efficient as I think it could be. But that was originally I think that was a result of one of the design goals, which was essentially O of one lookup for any individual element within the set. I think if that constraint is loosened, that opens up the possibility for other kinds of compression techniques and stuff like that will make it a better format for compressed data in memory, which I think is something that would be potentially interesting. I think there's still a question of like, okay, if we're going to have a stream processing system in, that uses these tools, what does that look like? Because Arrow as a format actually is not well suited for stream processing, right? Because it's a columnar format. So the conceit there is that you are sending in, many rows at the same time. Whereas when you think of stream processing, you think of either micro batching or individual rows like one by one, right? So there's no good, like, I think, translation layer between, okay, if you care about doing stream processing and you want to move to Arrow or like batch processing or larger scale data processing, how do you make that the transition, and what do the tools look like for that? I think that's still very difficult, right? And it's certainly like something we've done in InfluxDB 3, which is like translating to, Lime protocol, individual rows being written into the Arrow stuff. I think the distributed query processing is something that is probably going to, get more work. It's definitely something that needs more work within the Datafusion piece itself. I think later this year, in a couple of months, hopefully they're going to vote on whether Datafusion becomes its own top level Apache project outside of Arrow. My best guess is that's going to happen. And then what we'll probably see is like Datafusion will then have some sub projects, one of which I think will be around distributed query processing, which I think will be important for it really to become a contender and a competitor in the larger scale data warehousing space. What else? I don't know, like Parquet has gotten some interesting improvements along the way. I don't know, there was like GeoParquet for representing geospatial data. I think that's going to be super important. So, yeah.
This might be a little bit too far afield or too deep in the weeds, but there was also for a little while a bit of contest between Parquet and ORC as the preferred columnar serialization format. I'm wondering if you have seen that the dust settle around that and there has been a general consensus around one or the other, or if those are still kind of a case-by-case basis, do what you think is right for different use cases.
I may just be biased because, I'm I'm looking for Parquet, but I remember that being a thing. And I remember looking at both formats, from a high level back in the day, but I don't really see ORC as a format coming up nearly as much, right? It seems to me that Parquet has kind of won the, the mind share largely. And that's what people have kind of coalesced around. Now, of course, because we're talking about data at scale, there's probably like mountains of data in people's like data lakes and data warehouses that is represented as ORC. So that's not going to go away. But by and large, what I see is that Parquet seems to be the standard format that all the big data vendors are coalescing around.
I've been seeing a similar thing. And then to the point of streaming and record-based digestive data versus the columnar approach for Parquet and Arrow, I know that Avro and Parquet have a defined kind of translation method of being able to compact multiple Avro records into a Parquet file. And I'm curious if you're seeing anything analogous for the Arrow ecosystem of being able to maybe manage that translation of multiple Avro records batched into an Arrow buffer that can then subsequently be persisted into Parquet, or using that Avro to Parquet translation as the intermediary to then get loaded into an Arrow buffer.
I haven't really seen that. It's pretty easy to go from Arrow to Parquet or Parquet to Arrow, right? Because they're, Parquet's within the Arrow umbrella. So people at the project, in the various projects have created a bunch of like translation layers to do that. I really haven't seen any like rise of like, oh, these like row-based formats into either Arrow or Parquet. It just seems to be like kind of one-off. I honestly, I don't see Avro come up that much. So mainly I think what I see the most, what people care about is like JSON data, just because it's so easy, to change between different languages and different services. And honestly, I see protobuf more than Avro or anything else. And I think that's maybe because of, the popularity of gRPC.
And as you have been investing in this ecosystem, building on top of the different components, I'm wondering what are some of the most interesting or innovative or unexpected ways that you have seen some or all of those pieces used together?
So honestly, stream processing was a surprise for me, because I didn't, when I think of like Arrow and Datafusion, like I wasn't originally thinking that people would use these things for stream processing systems, right? I think more like they're around like batch processing and I execute a query against this data, whatever. So seeing people pull that stuff into stream processing systems has been very surprising. Elsewhere, I'm not sure. Like I think so. I've seen a few like observability solutions start to look seriously at using Parquet as the persistence format. That's a little surprising too, mainly because like when I think about observability, it's largely like, oh, you think of like metrics, logs, traces, right? And generally what people have done is they've created specialized, formats and backends for each of those individual use cases. So I've seen, some people start to look at seriously at having Parquet represent like any of that kind of data, which I think to me, that's definitely like one of our visions long term, is that being able to store any kind of observational data in Influx and thus in Parquet. But to see more observability vendors start to look at that seriously has been a bit of a surprise too.
And in your experience of working in this space, rebuilding the Influx database and investing more into the Arrow ecosystem, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I mean, one of the lessons, which is somehow a lesson I always need to relearn as a software developer, is things always take longer than you expect them to take. So this project, like I said, I started seriously thinking about it about 4 years ago. Really serious development on it for the last 3.5. It's basically just a long road to create this kind of system. So there's that. I've been pleasantly surprised by the adoption, by actually the level of contribution from outside, people at actually, companies of very significant size, has been also a bit of a surprise. Like I think they're for companies that reach like, crazy scale, which are, companies that the names of, like. I think many of them are contributing to these projects because they kind of have to like create their own things, because literally nobody on earth has the kind of scale problems they have, except for maybe like 10 or 20 different companies. So they end up having to roll their own solution. And again, I think the fact that these companies are contributing is something I didn't expect, particularly this early on. And I think that speaks to, the thing we were talking about earlier, which is like, what kind of platform risk is there to adopting this code? And it's like, well, the alternative is you create all this closed source software that is really like, this is not the problem you're trying to solve. This is just like the problem you have to solve to get to the problem you're trying to solve. So that's been like, I think a pleasant surprise seeing this, mature over the last few years.
And for people who are looking to build data systems, data processing engines, what are the cases where the FDAP stack is the wrong choice?
So I don't think it's particularly designed for OLTP workloads, right? So, traditional relational databases and stuff like that. Like there are places where, you can, it would make sense to have it as like essentially like an interface point. But I mean, you could certainly use like Datafusion as your query engine in an OLTP workload. But to me, it wouldn't make sense to use like Arrow as a way to ingest data, or Parquet, because really when you think about OLTP workloads, you think about individual requests with individual record updates and stuff like that. So I really do think these tools are more geared towards larger scale analytical workloads against, data that you can largely view as immutable, right? This is like observational data and stuff like that. So, yeah.
And as you continue to build and iterate on the new version of InfluxDB and invest in the Arrow ecosystem and the components we've been discussing, what are some of the things you have planned for the near to medium term, or any particular projects or problem areas you're excited to dig into?
So as I mentioned, the thing I'm most excited about is essentially like more integration, adding support for Apache Iceberg. So what that's going to so there's already like a Rust project to do Apache Iceberg, but it's not like fully baked yet. So we may need to contribute to that, or maybe the people who are working on it will get it fully baked before we actually get to the point where we're pulling it in. So Apache Iceberg is a big thing. I think in the medium term, the distributed processing stuff in Datafusion is going to be super interesting. And then from InfluxDB's perspective, as I mentioned, like we have right now our commercial distributed version of the database, but this year we're coming out with the open source version of the monolithic single server version of the database, and getting that open source piece out there with like a new version 3 API that kind of represents a much richer data model than previous versions of InfluxDB, that takes advantage of what you can do with Arrow and Parquet as the formats. That I'm actually really, really excited about, because then I really think that from a technology perspective, InfluxDB will actually be able to fulfill the vision that we've had all along, which is that essentially it is useful for any kind of observational data you could think of, not just like metrics data from your servers or networks or your apps, right?
Are there any other aspects of the work that you've been doing on the InfluxDB engine, the work that you've been doing investing in and building on top of the Arrow ecosystem, or the overall space of how the Arrow ecosystem might influence the future direction of the data processing ecosystem that we didn't discuss yet that you'd like to cover before we close out the show?
I don't think so. Like, I think we kind of, I guess like, more broadly, like the way I view like the data space right now, when you're talking about these like analytical data, is there's this kind of like distinct separation between like data warehousing on one side, which is these large scale analytical queries and stuff like this, and like stream processing on the other, which is more about like real-time data as it arrives. I think the trend, like really when I think about those two things, like ultimately like what developer wants and what users want is basically some magical oracle in the sky that they can like send a query to where the result will come back in, sub 50 milliseconds. If we had that, we wouldn't need stream processing. We wouldn't need like all these different things. But I think as the technology improves and things get better and better, data warehousing is going to become more real time, and the real time pieces are going to move more towards like data warehousing, because ultimately like people don't want to think about separating stream from data warehousing, whatever. And one of the things I'm excited about is essentially the idea that these different building blocks could potentially be the things that people use to kind of close that gap and create, a big data solution that works either for real-time data or for, big scale data warehousing.
But I thought people liked reinventing the Lambda architecture.
Oh, no. Yeah, they do. They do.
They just like to call it something new. Maybe it's the Kappa architecture. All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
The biggest gap? Oh. I don't know. I don't know, actually. Obviously, like, I think the most interesting side of this is essentially like, time series data, and basically being able to do analysis on data as time series. So that's our focus. That's what I think is the most interesting thing right now. But I still think that's an unsolved problem by us or anybody else. So that's what we're working towards.
All right. Well, thank you very much for taking the time today to join me and share the work that you've been doing, both contributing to and building on top of the Arrow ecosystem and the components thereof. It's definitely a very interesting area of effort. It's great to see the work that you and your team are doing to help bring all of us forward in that space. So I appreciate the time and energy you're putting into that, and I hope you enjoy the rest of your day.
Cool. Thank you.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.